Okay, 2.3 is a continuation essentially of 2.2. As we mentioned, it's formulas and problem solving. We talked about last time the structure of how we tackle word problems. Remember, problem solving just means word problems. And we have two objectives in this section. The first of which is to solve a formula. Formula for a particular variable. And then the second thing is to use formulas to solve problems. So I've got a big list of formulas here. These are the most common. Not all of the formulas that we'll need the entire semester, but this is a good place to start. So the first one is the interest formula, and this is what we call simple interest. So interest is principal times rate times time, and the variables we choose for those traditionally is I equals capital P for principal, R for rate, T for time. And this time is always in years. The next one, area of a rectangle, is length times width. So area equals L times W. The distance formula, D, not a capital, lowercase d, equals rate times time. Circumference of a circle is 2 times pi times the radius r. So notice we like to use r for a lot of things, rate, an interest rate, a speed rate, and r for radius. So just keep that in mind. Letters get reused. And then volume of a rectangular solid, a box, is always capital V equals length times width times height, LWH. So there's some other formulas you can see down here. We're going to get to another one in a little while. But the first example, solving V equals LWH for H. So this is, we divide by LW, divide by LW, and we get H equals volume over length times width. So a lot of times these are the base formulas, but you're not always going to be looking for interest. You're not always going to be looking for distance. So we need to be able to solve any equation that we're given or any formula for a specific variable. So I've got some practice problems here that'll get you going on that. Solving the interest for P, solving circumference for R, solving this two-variable equation for Y, and solving this, the area of a trapezoid, for little b. So you can practice those. So now we come to the example, and this is compound interest. So if you want to write yourself a little note what this formula is for, this is compound interest. So it's related to our other interest formula. P is still the principal. Now principal is what we call an initial investment or an initial amount. It's your principal amount. R is still interest rate. The N is the number of compoundings. Basically, it's how many times a year you get more money. So this is compoundings per year. And T here is time. Again, in years. So similar to our other interest, but instead of one interest payment, we have compounded interest. Compounded interest is always better than simple interest. And so we want to figure out what we need to do here. It says a couple just received an inheritance of 10 grand and plans to place all the money in a savings account that pays 5% compounded quarterly to help their son go to college in 3 years. How much money will be in the account in 3 years? So here we're actually looking for A. So what we want to do is identify our P, our principal, is 10,000. Our rate is 5%. I'm going to write that as a decimal, 0.05. Our T, our time, is 3 years. And then our N comes from this word here, quarterly. Quarterly means every 3 months. It's 4 times per year. January, April, what's 3 months later? July, and then, no, once a quarter. No, it's 4 times. It's quarterly. I don't know months. That's why I'm a math teacher. Okay, but anyway, our n is 4. So now we're going to take all of our numbers and pop it into our equation. So A equals 10,000 times 1 plus 0.05 over 4 to the 3 times 4. So we have 10,000. 0.05 over 4 is 0.0125. So this is 1 plus 0.0125 to the 12th. And this is a calculator problem. You will need a calculator to do this. And when you simplify it all down, we get $11,607.25. So in 3 years, they'll make a little under $1,700. Now the next problem uses a different one of our formulas. It says the average speed by a cyclist across the continental United States is 15.4 miles per hour, and this is by a guy named Pete Penseers. I don't know how to pronounce that properly. If he traveled a total distance of about 3,107.5 miles, that's roughly what it is from coast to coast, give or take a couple quarter miles or so. At that speed, 15.4 miles per hour, we want to find how long it took him, and we want to write our answer in time, our time in days, hours, and minutes. So let's start with what formula we need. Well, we have a speed, we have a distance, we want time. So we're going to be using our distance formula. D equals ST or D equals RT. Sometimes called the dirt formula, sometimes called the dust formula. Rate is your speed is your rate. So our distance was 31007.5. Our speed or our rate is 15.4, and our time is unknown. So we divide by 15.4, and we get T equals 201.79. Now we need to know, what is this T in? Well, we can think about what the units are for all these. So this is miles, 3,107.5 miles, divided by 15.5 is miles per hour. That's miles per hour. Well, miles divided by miles per hour gets us miles times hour over miles using our rules for fractions. Miles over miles cancels. And that means that this is in hours. Well, we want time in days, hours, and minutes, because I don't know what 201.79 hours is. So what we do is divide by how many hours in a day. So we divide this by 24, and we get 8.41 days. Okay, that's good. I still don't know what 0.41 days is, so I'm going to take this 0.41, and I'm going to convert that back into hours. So 0.41 times 24, this gives us 9.84, and this is hours. So now I have 8 days, 9 hours, and 0.84 hours. Again, I don't know what that means, so we're going to times that by 60 minutes in an hour, and we get just about 51. I think it's 50 point something. So our final answer is then 8 days, 9 hours, and 51 minutes. So this is the right context. This is the right interpretation of this problem, because it wanted days, hours, and minutes. And now, if you tell someone the fastest person to bike across the continental US took 8 days, 9 hours, and 51 minutes, every single person will understand what you mean. So on the back side of this, there are 2 practice problems similar to the ones we just did for you to work on. But this has been 2.3, Formulas and Problem Solving.